All right, this is going to be the last video for Chapter 2, and we'll have two things to talk about today. I'm sorry, three things to talk about today: significant figures, rounding, and graphs. So let's go ahead and get started. Let's look at how we're going to learn how to count significant figures. What we're going to do is you're going to pretend like your number is always the United States of America. And on the left side of your number is the Pacific Ocean. On the right side of your number is the Atlantic Ocean. Now, with the Pacific Ocean, that means your decimal is present. So if you're given a number and you can actually see the decimal in the number it's given to you, that means the decimal is present. So the P represents Pacific Ocean. So that lets you know that you need to start counting your numbers on the left side of your number that you're given. And once you start counting, you never stop until you get to the other side of the number or the other side of the USA. Now, the one rule you need to remember though is you start with the first non-zero number. So you never start counting with a zero. You start with the first non-zero number, but once you begin counting, you never stop counting. Now, if you're given a number and you don't see the decimal, like you would have to place the decimal yourself, then that means the decimal is absent, and that stands for Atlantic Ocean, so that means you would start with the number farthest on the right. And you would start on the right side of the number. You always start with the first number other than zero and move all the way left across the United States or across your number and count the numbers until you run out. So let's look and see how this works. All right, let's do a few examples. Your first example is 7.006. So you start counting on the left side of the number because the decimal is present. So you go to the Pacific Ocean side and you start counting with the first non-zero number. So that would be 1, 2, 3, 4. This number has 4 significant figures. Your second example is 3,023. There are no decimals present. They're absent. We can't see them. So we start on the right-hand side of the number and we start counting with the first non-zero. 1, 2, 3, 4. There are 4 significant figures. Remember, once you start counting, you never stop. 0.35, the decimal is present, so we start on the left-hand side with the first non-zero number, 1 and 2. So there's 2 significant figures. And 90 only has 1 significant figure because you start on the right-hand side since the decimal is absent. You skip the 0 since that's the first number and count your 9. Now let me let you do some practice. I would like you to pause the video, do these 1, 2, 3, 4, 5, 6, 7 problems, and tell me how many significant figures they have. Pause the video, resume it once you're ready to look at the answers. Make sure if you got any of these wrong, make sure you jot a little note about it or write a question or circle it or something so that you know to ask me about it when we come to class. Now let's look at we're going to work on calculating with significant figures. Now, when you're calculating with significant figures, the answer, like if I do 5 times 3, okay, 5 times 3, I have 1 significant figure in 5, 1 significant figure in 3, and so the answer I have cannot have more significant figures than the data I had in my problem. So my answer would need to have 1 significant figure. Now let's say if I did 5 times 10, 5 times 10, my answer would still have to have 1 significant figure because 5 has 1 significant figure, 10 has 2. And you cannot have more significant figures in your answer than the least amount of significant figures in the problem that you're working. So let's look at this. How many significant figures should you have with these mathematical problems? I'm going to go ahead, we're going to do 5.0 times 3.0 together. They both have 2 significant figures, so that means the answer will have to have 2 significant figures. And remember, it's always the least amount of significant figures given to you. That's how many your answer should have. So go ahead and pause the video, do the other 3 on this page, and then resume the video when you're ready to look at your answers. Now, 7.5 has 2 significant figures. 7.87 has 3. So the least amount of significant figures given to you is 2. That's why your answer has to have 2 significant figures. If some of these you did not get right, make sure you jot down a question so we know to go over it in class. Now, let's look at rounding numbers. Sometimes what happens when you do a mathematical problem, you get 10 different numbers, but your answer only needs 3 significant figures, and so you have to cut that number off at a point, and so rounding is important. Now, calculators do a great job at performing the math calculations for us, but like I said, they'll give you a lot of numbers for the answer, and sometimes you only need 2 or 3 significant figures. So let's just have a rounding reminding lesson, because this should be something that you've already learned. But you always figure out your number of significant figures you need. You look to the right of that last significant figure, and if it's a 5, then you raise that high. Let's look at an example. All right, so here's an example of a mathematical problem. We have 3.2 times 4.35, and maybe we were multiplying something together in the lab. What you would do is, since 3.2 only has 2 significant figures, right, and 4.35 has 3, that means our answer needs to have 2 significant figures. So we have to figure out where 2 significant figures is. If the decimal is present, that means we start on this side, so we have 1, 2. So we need these numbers, right, to have 2 significant figures. And what you do to round, you look at the number to the right of your last number. If it's a 5, raise it high. So my answer would be 14, because this is 9, which is greater than 5, so I raise this 3 high to the next number. Now, if we were doing something else, and let's say our answer was 13.03, what we would do down here, we needed 2 significant figures, we knew we would need these, and then we look to the number to the right. Since it's not 5 or higher, we don't raise it high, so our answer would be 13. So let's practice some of these on our own. All right, so let's look at this example, 4.5780323. If you needed this number in 3 significant figures, what would the answer be? And if you needed this number in 5 significant figures, what would the answer be? I want you to pause the video, figure out the answers, and then resume once you're ready to check them. All right, so if you needed 3 significant figures, it should be 4.58, because the number next to the 7 is greater than 5, so we need to raise it high. And I should have put up here, if it's greater than 5, raise it high, not if it's a 5. So if it's a 5 or higher, raise it high. And then down here, if we needed 5 significant figures, it would be 4.5780, because next to the 0, the 3 is lower than 5, so we don't raise it high. You keep it the same. Now, the last thing we need to talk about is graphing and organizing data. When you do a lab experiment, a lot of times you might do, when someone's really doing a lab experiment in the real world, they might have 100 different trials. And if their boss wants to see the results of the lab, it's very cumbersome for that boss to have to look through 100 trials and figure it all out himself. So, because that's your job. So the way we present scientific data is in a graph, and this helps us present it in an easy-to-read format. You need to know that we use graphs to make data into an easy-to-read format. Now, the types of graphs are line graph, bar graph, and circle graph. Sometimes the circle graph is called pie graph, so just be familiar with both ways. So let's look at an example of a line graph. This is an example of a line graph, and line graphs help show the relationship where the dependent variable changes because the independent variable is changing. Now, the line graphs always show continuous changes. The x-axis, which is the one that's horizontal down here, that is the independent variable always. So on this graph, we know the independent variable is the balloon diameter. The y-axis is the dependent variable where it's listed. So we know the dependent variable is lung volume. Now, the units of measurement, you see how down here on the x-axis it goes 2, 4, 6, 8, 10. Those are in consistent increments of 2. Your units of measurement must have consistent increments. On the y-axis, it's in increments of 1,000. It doesn't matter what increments you decide to do if you're making a graph, you just have to make sure they're consistent. Now, down here at the bottom, it tells us that slope equals the rise divided by the run. And you can also do that by the change in y, change in x. And when you use change in y, change in x, I think you should all know this because this should have already been in math. But you take 2 points off the graph, you subtract the y coordinates, and then divide them by your subtracted x coordinates. And if you don't remember how to find slope, make sure that you jot that down and ask me in class so that we can go over it. Now, the bar graph is useful when you want to compare values. And this is a better choice than a line graph if you're wanting to show single values for a lot of different items. And lastly, we have our pie graph or circle graph. And these are good when you want to show data that are parts of a whole. And these always display in percentages, information in percentages. And so make sure that you know the difference between these three graphs. Also, hopefully we're going to learn how to make these three graphs. You should already know how to do that, but we will also maybe do some practice on that. So I need you to do a summary now. For your summary today, I would like you to write a note to an absent student. And let's pretend that they didn't get the video to watch, so they didn't know they were supposed to watch one. So I want you to write them a note of everything important they needed to know from this video so they don't miss anything. All right, I'll see you in class.